Okay. Hello, and welcome to the Water Research Foundation's webcast on Project WRF 5155, Developing Strategic Consumer Messaging for Microplastics in Drinking Water Supplies. My name is Ashwin Danasekar. I'm a Research Program Manager at the Water Research Foundation, and I'll be your moderator for this webcast. I would like to run through a few housekeeping items before we get to introducing our presenter for the session. You can submit questions through the question box at any time throughout the webcast. It is located to the left of your screen. We will hold a dedicated Q&A session at the end of the webcast. You can download the slides from our website. A recording of this webcast will also be available after we are done here. There is also a link to the project page under Event Resources. Please take a moment at the end to answer the 3 survey questions that pop up. This will help us hear your voice and continue to improve our future webcasts. Now that we got that out of the way, I would like to introduce our presenter, Brent Alspa. Brent holds both PS and MS degrees in civil and environmental engineering from Cornell University. Brent joined Arcadis in 1997 and serves as the company's Director of Applied Research. He was a recipient of the George Warren Fuller Award in 2022 and is the immediate past chair of the AWWA Water Quality and Technology Division Board of Trustees, also serving on the advisory and editorial boards for Journal AWWA, Upflow, and AWWA Water Science. I will now pass it to Brent to walk us through his project.
Great. Thanks, Ashwin. I want to confirm, can you hear me okay?
Yes, we can.
All right, great. Well, first, thanks, Ashwin, for the introduction and to everyone participating in the webinar out there. It's interesting that we got nearly 500 registrations for the webcast, which is interesting considering this is for what I'll call an emerging contaminant, for which there are no enacted or even proposed regulations at the state or federal level, and for which things like health effects, occurrence, and treatment efficacy are not nearly as well understood as we would like them to be. So there's a lot of interest in this topic. And I'll just give a quick point of note about how small ideas can ultimately generate interesting results. The genesis for this project came after a presentation I gave about microplastics, I believe pre-pandemic. And after that presentation, someone reached out to me from a utility, I believe in Tennessee. I didn't know this person or the utility, but the question was, well, what should I say to our consumers that reach out to us about this issue? And I gave what I thought was a pretty respectable response, but I thought, I wish I could do better, and we should be able to do better. So fast forward to where we are today, having now completed a project on this subject and having generated these resources. To that end, I will just quickly go through some acknowledgments, not the least of which, of course, is Ashwin and Valerie behind the scenes, who does a lot of work to help us to get to where we are today, as well as the Project Advisory Committee shown here and their feedback over the course of the research, and the various partner organizations that participated as well. This is a tailored collaboration project, so I'd like to first acknowledge the Golden State Water Company here in California, who served as the sponsor utility for this effort. And then the 6-7 utility co-sponsors that are shown here, and they span coast to coast, Atlantic to Pacific, to the southern down in Texas and up in the upper Midwest as well across the country. And also the American Chemistry Council, which was a non-monetary contributor to the project. And they were an important inclusion because in having conversations with them about microplastics that predated this project, it turned out that they have also conducted consumer research on microplastics, albeit not with respect to drinking water, but it's interesting that the results of their own work corroborated some of the findings that we had as well, and they were willing to share some of those responses with us. Then just in terms of quickly defining the need, if it's not already apparent, if you've seen me talk about microplastics before, I will often lead with this slide because the numbers are so staggering. So though it's shown here is in the mainstream media, an article in The Guardian. And this was profiling a study conducted by the University of California at Santa Barbara for the Nature Conservancy in 2019. And so for this 1 year alone, they found 13.3 quadrillion plastic fibers in California's environment. Now, of course, quadrillion sounded a lot more ominous before June of 2022 when the US EPA released the advised health advisories for PFAS, but still, it's a very large number. Now, I'll note that at least at the time, this work had not yet been published or peer-reviewed, and to my knowledge, it still has not been done so. However, even if it's off by, say, an order of magnitude, it's still a very, very large number of plastic contaminants. And when you think about, if you multiply that by other types of plastic particulates, so not just fibers, but fragments of plastics and particulates themselves, and over the course of not just 2019, but other years and other geographies expanding beyond California, you quickly can understand the magnitude the microplastics pose in terms of contamination. So hopefully you've already started to understand that microplastics are everywhere, and that does include our water supplies. And I'll spend the next couple of slides sort of framing up why we might be interested in this, why we have 500 registrations for this particular webcast. And a lot of that starts in California, where prior to 2020, the state developed some legislation, and it required the regulator to adopt a definition in 2020, followed by standard analytical methods, which were approved by the state in 2021. Then following that, there will be, hasn't occurred yet, but there will be 4 years of sampling at select drinking water treatment plants throughout the state, and the results will be reported in consumer confidence reports. And so the graphic here simply shows the policy guidance that they issued about 2 years ago, talking about various aspects of the monitoring program. And I'll point out that for those of us working in the microplastics research space, as we like to say, the literature is a mess. And for that reason, even if as the science evolves, and it is doing so rapidly, the sampling methods, the analytical methods that are used in the California monitoring program ultimately are modified. One thing that's very important is that this effort that California is taking on will result in a large database of what we know are apples-to-apples comparisons. So even if the science continues to evolve, and it will, this data set will be consistent. And so you'll be able to compare one treatment plant or one source water microplastics results with another one. And that will be a notable advancement in our understanding of microplastics. And across the US as well, there's interest both among utilities and the general public. We know that third parties are already sampling water supplies as well, not just in California, but elsewhere. And the US EPA notably listed microplastics as a potential contaminant under the CCL 6. So that hasn't been finalized yet, but they did propose that maybe they would consider microplastics in that context. And so for all these reasons, consumer concern is expected to increase. And it's not just in California. In New Jersey, recent legislation was enacted, and I'll highlight this here, which you can't read, but we'll blow that up. So essentially, their legislation directed their state's Department of Environmental Protection to take actions concerning ID and testing of microplastics in drinking water. And effectively, the details notwithstanding, this emulated to a large extent what California has already enacted. And it's not just California and New Jersey, but the city of New York had proposed monitoring for microplastics. And to the best of my knowledge, this has not yet been implemented, but it does just underscore that interest continues to grow. And if you consider California and New Jersey and New York City, that's about 57 million people, or 1 in 6 in the United States, could soon live in a jurisdiction in which the waters are monitored for microplastics. So not an insignificant amount of interest. And at this point, if we were in person, I might ask for a show of hands to say, hey, are you not sure whether microplastics are a problem? And typically when I pose this, there's sort of a tepid response. So you can sort of do this on your own, but then I would sort of reframe the question, okay, who is sure that microplastics are a problem? Very few hands go up. Who is, by contrast, sure that microplastics are not a problem? And likewise, very few hands. And so what that infers is customers alike are, both the people in the audience, people aren't sure, but the customers are not sure either. And that's exactly why they'll call their utility to inquire about microplastics, even if their utility specifically is not required to sample. You're not in California, you're not in New Jersey, but you heard the monitoring is going on, or you just heard about microplastics in drinking water. I might call my utility to find out more about the subject because I'm concerned. So to that end, here we are with WRF 5155. And this work is critical because both the California results and the New Jersey sampling results will eventually be publicly available. We know environmental advocacy groups are already conducting sampling around the country. So customers will contact their water suppliers, and perhaps some of you are at utilities where customers are already doing that, and I've heard anecdotally that that has been the case. But most utilities have no experience with microplastics or the associated concerns, which is understandable considering the myriad of other important issues that you have to contend with, from lead to PFAS to workforce issues and infrastructure repair. So microplastics are far down the list for things that you've been thinking about. And of course, to date, there have been no outreach resources for utilities, which is what this project now has changed. The two research objectives for this work were, first, to build water industry institutional knowledge about microplastics issues of greatest consumer interest, and then generate appropriate messaging to address those concerns in response to customer and media inquiries. And to the best of our knowledge, this really represents an unprecedented proactive customer outreach effort. And I use the word proactive not in terms of encouraging utilities to reach out about microplastics. And that's one thing that the American Chemistry Council's consumer research discovered and was corroborated by ours. If you ask a question to the public, are you concerned about microplastics in drinking water? Chances are they'll say, no, should I be? And it's almost like a self-fulfilling prophecy for people who weren't previously concerned. Now they are, because you've asked the question and they feel like you must be doing that for a reason. So rather than open Pandora's box, the intent expressly of this work is not to necessarily cajole or enable utilities to reach out proactively when their customers are not even asking about microplastics, but rather primarily when customers or media contact utilities themselves, how should utilities best respond to those inquiries? I'd like to acknowledge the research team quickly before I move into the more detailed content. Not just an Arcadis effort, of course. I have my co-PI was Patsy Tennyson from Katz & Associates, which is one of the major communications firms operating in our space. And also Dave Metz from FM3 Research, which is a firm that has conducted a lot of its own consumer research, both for emerging contaminants and other aspects of drinking water. I'd like to acknowledge my own colleagues, Serena and Alma. Serena has moved on from Arcadis to now work for MODOC in Southern California, one of our utility clients. Also to acknowledge Karen and Emily and Carlene from Katz & Associates, as well as Lucia from FM3 as well. And all this sort of many hands made good work of the research, which I will shortly discuss. So quickly, in terms of the research approach, we started with an information collection phase and conducted a couple of workshops. Task 3 was the fulcrum of the work, which is the consumer survey, and then developing the report in Task 5. And Task 6, this industry briefing webinar, which is where we are at this point in time right now. And I'm going to start with this consumer information synthesis, which is comprised of tasks 1 and 2, this initial information collection effort, and the following strategic planning workshop to frame up that consumer survey. The purpose of that effort, as shown here, was to prepare workshop participants who probably know little or nothing about microplastics coming into that workshop to enable this meaningful discussion of consumer messaging about microplastics at that point in time and create this uniform baseline of understanding for all the participants to work from. So in gathering this information, we organized it by topic area for microplastics, so occurrence of these contaminants, sampling methods, analytical, water treatment process, removal efficacy, and the toxicology of these contaminants. And within each of those topic areas, we focused on 3 things. What might consumers know about microplastics in drinking water, or what could they be expected to know? What concerns might they have, and what questions might utilities get? And then what additional background is helpful for utilities to understand sort of beyond what consumers might know that just is helpful for the purposes of internal knowledge and discussion. And we captured all this information. So in addition to the results of the survey, which I'll show, this information as well is captured in the research report. And I'm going to walk through some of that stuff because it's interesting content by topic. So starting with occurrence. And what might consumers know about occurrence of microplastics in drinking water? This is probably the area they know the most about because it gets the most media coverage. Where are microplastics being detected? That's sort of the buzzword that gets captured by the media, and they publish stories. So they also probably know that microplastics and plastics broadly are ubiquitous in the environment. and they may have heard things about the occurrence in infant formula or in infant feces. There were a couple of prominent studies published at the beginning of 2023 about detections in human blood and lungs with a high number of detections, the high percentage of detections. It can also occur in the placenta, and consumers may know that, as well as in drinking water and bottled water, as you might expect. In terms of additional background on occurrence for utility reference, there are limitations of these studies that are not reported in the media. So, for example, the studies I mentioned about human blood and lungs, the statistics were very compelling, but the sample size was very small, in the order of, I want to say 10 to 20 in each case. So yes, those have statistical significance, but it's a long way from saying that microplastics are in everyone's blood or in everyone's lungs. But that information, those nuances about that study are very seldom reported in the media. And that data reported in the media may not be reliable or comprehensive or readily comparable if I'm thinking about comparing one study to the next. But those nuances, the reporters don't often have the utilities to even ask those questions and understand the limitations of those studies. And of course, drinking water is not the only way in which we might ingest microplastics. You might get them through food, or probably what's the most significant vector for exposure is inhalation. And then some questions that utilities might get as far as microplastics occurrence go: are they present in my drinking water? Are the concentrations relatively high? What concentration of microplastics is concerning? Do microplastics concentrations vary in different parts of the distribution system? Does the plastic pipe in my residence contribute microplastics to my water supply? Does my proximity to industrial areas make a difference in microplastics in my water? Does bottled water have higher concentrations of microplastics than my tap water? Are microplastics regulated in drinking water supplies? What's the maximum allowable level of microplastics in drinking water? And then moving on to sampling. What consumers might know about this, frankly, is very little, but they may have some possible awareness of contamination of samples due to airborne deposition or synthetic clothing, which could shed plastic particulates into samples. But generally speaking, inquiries about microplastics sampling are probably more focused on requests for sampling or clarification about sampling that they feel like may already be being conducted at the water treatment plant, not details of the sampling implementation itself. And some additional background for utility reference on this subtopic is that sample contamination minimization is a very important consideration that can affect results, namely, among other things, what I mentioned, airborne deposition. And you have to make sure you're not shedding microplastics from most of our textiles, your synthetic clothing, which again can contaminate the sample. Now, notably, the ASTM standard referenced here, which is the only standardized guidance for sampling, does not contain any information about how to minimize contamination during the sampling process or the use of blanks. So it's a potential limitation of that standard guidance. And because of these things, training is essential for samplers to make sure that you have some of these errors that can lead to sample contamination and therefore questioning of the results. A couple of anticipated consumer questions. Can I sample my household water for microplastics? Can you, the utility, sample my household water for microplastics? Given that plastic is all around us, how do you make certain that samples are not compromised? Again, just some questions that you might expect consumers could ask, anticipating that so you may be prepared if those questions do come up. Then with respect to analytical methods, frankly, consumers probably know very little, but there's a lot of important information for utilities to be aware of. The most prominent of which is that numerous microplastics attributes are of interest, unlike other potential contaminants like a pathogen like Giardia or Cryptosporidium, or let's say hexavalent chromium. Maybe we're only interested in quantity, whether it's mass or a particular enumerative count. But we're interested in many more things with respect to microplastics that's sort of shown in the table here. So going down that left column in terms of attributes, we might be interested in the enumeration of microplastics. So how many are there per unit volume of sample? What's the size of those particulates? That can make a difference for toxicology. What's the total mass concentration? What's the shape or the morphology of that attribute, of that contaminant? And then what's the polymer type of the microplastics? Because microplastics is not a monolithic type of material. It's a category of materials with lots of variation. And so from these attributes, there is a number of pieces of information that can be conveyed, but not any one attribute tells you everything we might want to know. So starting at the top in terms of enumeration, that will tell you, of course, occurrence or quantification. They tell you something about treatment efficacy if I'm profiling a process between the feed and the effluent of that process. And because the number of microplastic particulates probably has influence on toxicology, that's important to know as well, but it doesn't give us any information about the origin of the microplastics. And those same things are all true for particle size as well. Mass concentration also gives you occurrence quantification and to some degree treatment efficacy, thinking about, again, profiling feed versus effluent, how it's the mass concentration of microplastics present before and after a treatment process. But it probably, for this contaminant or class of contaminants, doesn't give you very much information about toxicology at all because it's a broad category. It includes polystyrene and polypropylene and other types of microplastic polymers, as well as added chemicals to those polymers. And so the total mass concentration of microplastics itself as a category doesn't really convey any meaningful information about toxicology. Then in terms of the morphology, it doesn't really help us quantify occurrence, but it may give us some information about treatment efficacy, thinking about maybe fibers which are long and more branched are more effectively removed than smaller spherical particulates. It may give us some information about toxicology and the origin of the particulates as well, thinking that fibers probably come from textiles, whereas maybe small spheres could come from industrial contamination. And then polymer type as well, those same three attributes apply, but doesn't tell us anything about the occurrence or quantification. And again, this is unlike any other type of contaminant that we deal with. So then going back down the list here, no single method provides information about all those attributes you saw. Some of the aspects of microplastics analysis can be automated, but others are much more costly, they're labor intensive, and they necessitate analyst training, at least with our current state of technology. Size resolution is an important limitation. Right now, the methods in California are confident down to a size resolution of 20 or 50 microns, depending on the method that's utilized. But of course, we want to eventually get to the point where we have much smaller resolution and can start to understand how many particulates may be present in 10 nanometers or less if we want to. And those resolution differences from methods, or if you're looking at studies in the literature, the lack of disclosure about what that resolution is complicates the comparison of occurrence data sets. So it's one thing to say, well, study A and study B found these two respective levels of microplastics in a drinking water supply. But unless you've told me what the resolution of the method is, it really doesn't let me know if those numbers are comparable. And then finally, the monitoring program being implemented by the state of California will improve method standardization for analysis in drinking water samples. And just a few questions that you might anticipate from consumers on the subject of methods. Can microplastics be detected in drinking water? What are the smallest microplastics that can be detected? What types of plastic polymer are or can be detected? And is there an in-home test for microplastics that's quick, reliable, or inexpensive that I can utilize to find out what microplastics might be present in my own water supply? Then in terms of treatment, there's probably very limited exposure to treatment efficacy in the mainstream media, so customers probably don't know that much about this subject. But their most substantive understanding, if they have it, is with respect to POU, point of use, or point of entry POE devices. And the reason is because the manufacturers of those devices want to underscore their value for something that may be of concern to you as a consumer. And so if they know microplastics are an issue, they're likely to say this device is very effective for removing microplastics which are probably in your home. And because of that advertising, the consumer is much more likely to know something about those devices than they are about whatever might occur at the treatment plant scale. And then some additional background for utility reference. The literature is somewhat limited on treatment. There's a number of studies out there, but there's a lot more that remains to be identified with respect to treatment efficacy and the variability of treatment and the factors that influence that. Removal percentages cited for the studies that are out there can vary widely, and the factors that influence those differences include the size, the shape, the density, the polymer type, the surface charge of the microplastics, the water quality matrix that surrounds the microplastics, like the pH, the temperature, and the treatment processes that are utilized. And all of these attributes are objective. We know what the size, the shape, the density are, and how that variation might contribute to fluctuations in demonstrated removal efficacy. But there could also be differences in QA/QC practices that contribute as well, and those are much harder to differentiate between one study to the next. And the next one here, I'll highlight the variability of that we're talking about here with respect to these different attributes can be minimized with the use of membrane treatment, that is membrane filtration, MF or UF, or membrane desalination, NF or RO. But these processes can contribute microplastics as well. I'll take a slight detour on this point because it's of interest and can shed some insight on the microplastics issues with respect to treatment. So, of course, this is where membrane shines. It's probably the best technology we have for removing microplastics that come into the treatment supply. Now, backing up a step, we know that our current treatment processes writ large are very effective for removing what I'll characterize as conventional particulates. But it's important to ask, how comparable are microplastics to conventional particulates? But we know these attributes are very influential for the efficacy of our treatment for coagulation, flocculation, settling, and filtration, which comprise conventional treatment. But if I highlight these things here, treatment processes generally, and conventional particulates, now I've changed that to membrane processes and all particulates, we know that membranes are much more effective. And the reason is because membranes reject particulates on the basis of size exclusion alone. So morphology, surface charge, density, none of that makes any difference. It's only with respect to size that these membranes reject particulates. And we know the rejection is very robust. So microfiltration, ultrafiltration shown here, we typically characterize the pore sizes as microns or 0.1 or 0.01 microns. But just to reframe that, that's 100 nanometers and 10 nanometers respectively. So we can reject all but the very smallest particulates. And then NF and RO, these are semi-permeable membranes without definable pores. So you might expect them to be almost an absolute barrier for microplastic particulates. So we see that we have very robust rejection of microplastics with membranes, assuming we can detect them, because as we mentioned, our current methods have some resolution limitations in the tens of microns, and we really don't know what the ecosystem looks like for nanoscale particulates. But can water treatment plants contribute microplastics as well? And you think about what comprises conventional treatment: filter under drains, tuber plate settlers. These are typically plastic components. Polymer is an interesting one because we actively add a plastic, which polymer is, to the treatment process for beneficial use. And thinking about advanced treatment process as well, whether that's ion exchange or carbon vessels, which are important today in the era of PFAS treatment, but not just those. Again, we're talking about membranes here. So whether it's MF and UF, and I'll characterize that as polymeric membranes because there are ceramic offerings for these membranes as well. But NF and RO, the membrane desalination processes, everything from the membrane material itself to the elements in which the spiral wound, the flat sheets are spiral wound, and the pressure vessels that contain the elements, all of those are plastic materials. And when you think about what we do to membranes, we backwash MF and UF, we flush the processes, we use aggressive chemical cleaning agents to reverse fouling, we subject them to mechanical stress, there's routine wear over the course of time, and the materials age and potentially can become embrittled. And all of those things can contribute to microplastics shedding potentially. And I've cited a study here at the bottom of the slide which suggested this. And of course, it makes sense intuitively that that would be the case. But to date, there have been no very rigorous studies demonstrating after I've backwashed my membrane filtration process or after I've chemically cleaned, then I would expect this detection of microplastics, if any, downstream of my membrane process. But it's certainly not impossible that could be the case. And thinking about other common components in the distribution or generally as well, piping, whether it's in the plant or in the distribution system, like PVC, that's a plastic component. Anything that's epoxy coating, that is also a plastic material. And then think about the chemical systems, everything from the storage tanks that contain the chemicals to the tubing that we use to transfer chemicals from the point of origin to the point of application, and the feed pump parts that accomplish that transfer, all of those are typically plastic in nature. So you can see there is certainly a potential for water treatment plants to contribute microplastics downstream. So just continuing on down the slide here, smaller particles, as you might imagine, could more easily evade treatment. And an important note, air deposition downstream of treatment has been demonstrated. So whether that's an air vent in the clear well or in the distribution system, whether it's an air gap in a storage tank for venting, those are all places where the airborne deposition of microplastics could occur past the treatment process. And then just to underscore, because of all these things we've talked about, quantitative characterization of removal can be misleading because there's so much variability and that difficulty in comparing apples to apples, as we say. Some anticipated consumer questions on treatment include, if microplastics are in water supplies generally, can they be removed? What treatment processes can remove microplastics? Can the processes in my local treatment plant remove microplastics? What treatment steps is the utility taking to remove microplastics? What can I do to help ensure my water is safe from this contaminant? What can I do to reduce microplastics concentrations in my own drinking water? Are POE devices effective? And what types of those devices are best for removing microplastics? They might also ask, will my refrigerator water filter remove microplastics? And what about boiling water? Would that remove these microplastic contaminants? Can water treatment plants or in-home devices contribute microplastics to drinking water? And I understand that plastic materials like polymer could be used in drinking water treatment. Is this a source? Now, I have this caveated because it's very unlikely that customers will understand this is occurring, but it's not impossible either. So as I mentioned in the previous slides, we do add polymer for beneficial use, of course, but just to be cognizant that this is potentially something consumers might ask about. And with respect to toxicology, after occurrence, this is probably the area that consumers know the most about because it garners the most media attention after occurrence. Concerns they may have seen in media reports could include inflammatory bowel disease or IBD, or the sorption of secondary contaminants and the consequent health effects of that sorption. Some additional background what's important to understand about this category is that health effect studies are very challenging to conduct, and that in and of itself could take up an entire presentation. But that complexity of conducting those studies is unlikely to be understood by consumers. They just expect you're going to conduct the studies and tell me if it's hazardous or not, but of course, it's not that simple. The mainstream media consistently overrepresents health risk relative to the studies they cover in the reporting. And there was actually a peer-reviewed study done to document this. So from the way the study authors frame up the risk, the media sort of takes that either knowingly or unintentionally and sort of magnifies that in their reporting, which may lead to more consumer concern that potentially is warranted. And of course, consumers are subject to conflating occurrence with risk, which we all tend to do. So what that means is they understand that microplastics are present potentially in my lungs or in my bloodstream, and therefore they are toxic, which could stand to reason, but it's not necessarily the case and may not have been demonstrated. And as we said, microplastics is a broad category, and the health risks may not be uniform from polymer type or from size or from absorption of contaminants and many other factors that underpin the wide variability of microplastics. And to date, no studies have definitively linked microplastics to significant adverse health outcomes. But of course, that could change, but this is the state of the science today. Questions that might get asked are, should I be concerned about the impact of microplastics on my health? Will they make me sick? What are the health effects of microplastics? Will microplastics impact my ability to get pregnant or produce viable sperm? Will microplastics cause IBD? Will microplastics cause cancer? And what about harming my baby? Are human health effects well understood? And how does the risk of microplastics compare to other contaminants in drinking water? All questions, again, that you might anticipate consumers could ask. So with the background of that, we're going to move on to the results of the consumer survey. Again, we use that information for context in our workshop, discussed microplastics, and developed the survey, which FM3 implemented. and that resulted in the consumer survey responses. So just to show the breakdown here, I'm a little bit a snafu in the graphics, but we're highlighting task 3 here. And we've limited this in the survey to just 16 questions with subparts and a target duration of just 15 to 20 minutes, because FM3's experience has shown that if you go beyond that, the attention span of the survey respondent tends to wane, and therefore the quality of your data declines. So you really want to make sure you can keep their attention by keeping within these constraints. And this slide just profiles an overview of the survey itself, when it was conducted, how it was conducted. I'll underscore a couple of points here. In order to get to the 95th% confidence interval, that is a standard benchmark that they shoot for in these types of surveys, they needed 400 responses. We had 501, so overshot that mark by quite a bit. But I also did want to note that this is a scientific, statistically significant survey of voters nationwide. It's not just a SurveyMonkey tool that was blasted out to whoever's ability to respond and whatever we get. It's very important to understand, because this is a rigorous Water Research Foundation project, that the survey likewise was scientifically rigorous. So what were some of the select survey findings? Generally, we asked what was the public's perception, sort of a warm-up question, of contemporary issues. And it's of note that among the many things listed here, from inflation, which has been a big deal over the course of the time which the survey was conducted, crime, taxes, tap water quality ranked at the bottom. So the least concerning among this list of potential consumer concerns, with only 23% considering that an extremely serious extremely serious concern. So we can infer from this then the public has substantial baseline confidence in drinking water quality. And we also asked, again, sort of warming up the crowd, if you will, the degree of satisfaction with various utility services. So water, electric, wastewater, cable or satellite TV service. Again, to our credit, the water service was ranked at the top of a list of utility services, with 86% expressing satisfaction. As you may expect too, nobody likes their cable or satellite TV typically, because when it goes out, it's always inconvenient, and it's not surprising potentially that wrecked last. But because of this satisfaction, we have an opportunity, therefore, to leverage that public trust as a tool to aid communication, whether it's with respect to microplastics or any other contaminant. Then, of course, we asked about microplastics awareness and concerns. So have you read, heard, or seen anything recently related to microplastics in tap water? And so with that, awareness tends to be relatively limited. Only 39% said they had at least some awareness, whether it's a little or a great deal. But among that subgroup that had some awareness of microplastics prior, that's 196 respondents out of the 501, 76% of that subgroup reported some level of concern, which underscores one of the points I made previously. Awareness suggests concern, and that theme sort of consistently came up over the course of this project. Then, in terms of confidence that the consumers have in the utility's ability to address microplastics, as shown in the graphic here, it really is sort of breaking down 50-50. So about a little over half were confident, a little over 40% were not confident to varying degrees, which again suggests here we have a clear opportunity to improve consumer confidence with respect to strategic messaging about microplastics in drinking water. Then we wanted to break down the analysis of where consumers' confidence lie with respect to water utilities' efforts to address microplastics. So going down the left column there, actions utilities might take include assessing the impact of microplastics in tap water, detecting their presence, treatment to remove microplastics, identifying the sources of microplastics found in tap water, and then communicating with customers about microplastics. So at the top here, you can see their area of most confidence is that they feel like utilities do the best job of all these potential actions is assessing the impact. And although we didn't frame it this way, it's reasonable to assume that by impact, they interpret that as toxicology. So 64% indicated confidence in the utility to assess that impact. And second on that list was occurrence. So they had 61% had either somewhat or were very confident about the utility's ability to detect microplastics. However, those are really the two areas in which the current state of the science is the most uncertain. We obviously don't know that much about the toxicology yet, as I mentioned previously. And because we can't detect microplastics down to the very small nanoscale that we would like to have a full understanding of microplastics occurrence, it really, there's a big gap in terms of our understanding. So we want to make sure that we only underscore what we know. So consumer perception here is out of alignment with the current state of knowledge. And I'll point out the one at the bottom that the communication sag about microplastics is not really surprising because most utilities have never had to message about microplastics, so customers have never heard anything from their utility about this subject. And because of that, they may interpret that as, well, they're not good at it because they don't do it, but the reality is they haven't have to. We want to make sure, though, that we're make sure that we don't underscore inappropriate messages in communication. And again, here we have a clear opportunity to improve consumer confidence with strategic messaging that we can conduct. Now, it's interesting to note that this effectively is a baseline survey because to date, microplastics monitoring has not been broadly and conducted in an organized way among water sources and in drinking water supplies. But that will change in California and New Jersey and potentially other places as well in the coming years. So it'd be interesting in the near future to conduct this again to understand how this perception may have changed after this monitoring has been conducted and after the results are published in consumer confidence reports and they've had a chance, the customers, to really dive into that in a more substantial way. So then we had trial messages prepared with respect to utilities being prepared to address microplastics, monitoring for these contaminants, being at the forefront of research, the professionals working in utilities that are actively engaged in this topic, the technology that we use to detect and remove microplastics, being vigilant about staying on top of the issue and proactively doing things to protect against microplastics. Now, I don't have time to go in and read all the messages today, but in terms of the topical messages, we have a little bit of an opportunity to understand the degree of confidence that these conferred. So going down, whether it's technology or being proactive, all the way down to being vigilant, all of the messages that we proffered were broadly successful for bolstering confidence, whether that was between 56 and 67% of respondents improving confidence, either somewhat or much more confident. After you've heard the message, I feel that much more confident. But the spread between the responses, as you see here, was not substantial. So maybe there's not a lot of difference necessarily, but we did note that the two messages that expressed some degree of uncertainty garnered the lowest increases in confidence. And these are things like, which is the reality, health effects are not that well understood, and we're still trying to get a handle on occurrence and treatment efficacy, even though those things are true, just indicating in this messaging that there was some element of uncertainty tended to make respondents less confident after hearing those messages. So expressing uncertainty, therefore, may hinder the effectiveness of our messaging. So some of the key findings about what messages were effective, any one of a wide array of topical messages, as you saw, about utility actions can be broadly effective for increasing consumer confidence about microplastics in drinking water. More focused, specific, and detailed messages are more effective than broad or general statements. And as we just noted, messages conveying confidence are more likely to elicit confidence in consumers than those that highlighted uncertainty, even though that uncertainty is the reality. And this isn't to underscore that you should indicate something that isn't true, certainly if we want to convey accurate information. But it is to say that if you can avoid discussing all the elements of certainty about microplastics, the messaging will be that much more effective. And this next one is very interesting, perhaps the most poignant finding from the survey in terms of what who are trusted sources of information. So we talked to the survey respondents about who do you trust and view them either as a trustworthy source of information about microplastics or a suspicious source about microplastics. And it goes down the list from doctors to water research scientists to utilities, the Water Research Foundation itself, nutritionists, and environmental organizations. And then the column to be cognizant of is that difference over at the far right. And what that represents is the differential between those that trusted a source and viewed that same source as suspicious. So the top, you see the doctor, 82% trusted that source, only 12% viewed that person with suspicion, and that difference, 82 minus 12, gives us the 70%. What you see here is there below doctor, there's sort of this sort of even trend of response differences, but then there's a huge leap from professors of water science at university all the way up to your doctor. So we know the personal physicians are by far the most trusted source about microplastics, even though your doctor is very unlikely to know anything about microplastics, much less about microplastics in drinking water specifically. But nevertheless, that is the perception of consumers. Local water utilities pulled somewhere in the middle. In terms of 6 of the 13 sources that we trialed are plus 22%. And then notably, the World Health Organization and environmental organizations were the least trusted at 13 and 15%, respectively. Now, that isn't to say that those organizations are not trustworthy. That is a perception among the customers, the consumers that we polled. So as you might expect, we've got a lot of demographic information about the survey respondents as well, and that information is appended to the research report. And as you might expect, any individual's confidence in these organizations who or environmental groups broke largely along political lines. So just keep that in mind as a data point. So what we know here, though, is there is a significant opportunity for the water industry to build trust by engagement with the medical community, whether that's with respect to microplastics or any other contaminant that may occur. So overall, some messaging strategies include, as a first, a category for general communications guidance. Don't proactively communicate about microplastics in the absence of specific information that needs to be or is required to be conveyed, because as we hopefully this gotten this point across, awareness translates to concern. Do capitalize on the public's instinctive trust in water utilities, because utilities are perceived to be prepared to address water quality challenges. Do keep in mind that the public seems to be overconfident in utilities' ability to detect microplastics and assess their impact. So avoid reinforcing those misperceptions to the extent that you can in interactions with customers. Do engage with medical professionals to facilitate effective messaging, because doctors garner a high level of trust, as we saw. And don't position WHO or environmental organizations as lead messengers or reference them in communications, because consumers perceive these sources as less trustworthy. Now, if you know your demographic breaks one way or another, that may be a different story, but because generally you're talking to a broad range of consumers with varying political views, you just might not want to lead with those messages, because you're likely to alienate some or maybe a significant portion of the customer base in doing so. And it isn't to say, again, they are not reliable sources, but the perception is very divided on that point. And then some guidance for responding to customer inquiries about microplastics. So don't offer messages that emphasize the ubiquity of microplastics, particularly in conjunction with uncertainty about health effects. As you might expect, if you talk about, well, microplastics are everywhere, we understand that, and the health effects aren't well understood yet, that just undermines consumer confidence and raises alarms that, oh my gosh, microplastics are all over the place and they could be affecting my health and we don't know. Do emphasize the wide array of treatment technologies that utilities already employ that may be effective in removing microplastics, because survey participants indicated their trust in the technology. Do emphasize the role of scientists or other trained professionals who are already working diligently within utilities, because the messaging about proactive roles of key individuals tended to confer confidence. Do stress the proactive nature of utilities' work on microplastics, whether that manifests itself as research like this project, partnering with organizations to delve into this issue, monitoring for microplastics, tracking important developments that our utility needs to be aware of. All those things, those proactive steps, tend to be more effective when you convey that to consumers. And then do express confidence in messaging, because messages projecting confidence were categorically better received than those that projected less confidence or uncertainty. So in getting to wind up the presentation, some additional resources of communications I will underscore. So if we characterize Project 5155 as response messaging, again, consumers reach out to utilities. How should you respond? How can you respond? What's effective for responding? But we have also been a part of a group, a volunteer group, working under the California Water Quality Monitoring Council to develop some informational messages that may go the other direction, so proactively outward. And that's in a specific context because, again, we know that in California and potentially in New Jersey, the findings from the monitoring programs will have to be disclosed in utilities' consumer confidence reports. So the mission of this volunteer group was to prepare a series of topical paragraphs about microplastics for inclusion in CCRs. And so we broke it out in terms of sources, so what microplastic sources are out there, occurrence of microplastics in water supplies, treatment processes and how effective they may be for removing microplastics, the health effects to the extent that we know them or don't, management of microplastics as an issue, and because this was specific to California, at least under the purview of the Water Monitoring Council, more details about California's monitoring program. And the idea in generating this information was keep it limited to 1 to 2 paragraphs, very simple and concise, using 80 words or less, avoiding demonstrative statements like, we know this is true or this is true, and then targeting sort of a 5th grade mentality, knowing that people's scientific ability varies widely across the board, and you wanted to make sure that the information was as accessible to as many people as possible. And the idea would be that between those topical modules, if you will, those 1 to 2 paragraphs on each individual topic, utilities can sort of pick and choose which of those topics they think are of most interest to their customers. They could use them as written or mix and match, or use them as a template to modify or customize for their own customer base, and then use that in consumer confidence reports for the obligatory messaging that may be necessary. So to date, this content is done. It has not yet been posted on a California website, but it will be, at some point that will be the case. And then when it comes time for utilities to need to put information out there in their consumer confidence reports, this content will be available for that purpose. So finally, in terms of research needs, and these are things we articulated in the research report that will improve communications either directly or indirectly, just taking the highlights quickly. So the strategies for further bolstering confidence, more work on what else might help consumers be more confident about utilities' responses to microplastics. Generally, the more we know about occurrence and treatment, the better messaging we can, the more specific, the more focused that messaging can be. And we know that specificity tends to elicit more confidence. Same thing for analytical methods. The more we know, the better our communications will be. The same thing for the toxicology of microplastics. Engaging the medical community, as we saw, will improve communications. Training with respect to how to communicate with customers about this issue, and then tracking consumer perceptions over the course of time. And I'll highlight this one here quickly, microplastics occurrence and treatment among a number of other good university studies that are being conducted right now. We have another research foundation project we're in the middle of at this point in time, the fate of microplastics in drinking water treatment plants, with the intent of profiling different unit processes in treatment plants to better understand not only treatment efficacy, but what other correlative factors help to influence that removal with respect to any one unit process. So media size, what coagulant type was used or dose, or what's the mixing energy and flocculation. All of those things matter with respect to how effectively microplastics may be removed. And one intent of this project is so not only to profile removal, but also try to correlate that removal with parameters that we can be aware of, or potentially could even control if we wanted to try to optimize removal for microplastics. And so with that, I will wrap up the presentation and entertain questions. I will note that the report is available on the Water Research Foundation website for downloading. And of course, Always happy to have a conversation offline about this topic. And certainly, if you are at a utility and you already received messages about, or you've received inquiries from customers about microplastics, we would be very interested in knowing what those are and trying to capture those over time. That will also have value in continuing work like this for us to better understand what consumers are asking, and then in turn, how can we respond to those inquiries better? So with that, the few minutes I have left, I'll turn it back over to Ashwin and answer whatever questions I have time for.
Thanks, Brent. Thanks for the comprehensive presentation. We do have a few questions popping in, and that can be a quick segue to our Q&A session. The first question I see here is an inhalation likely a much greater risk than ingestion? Would you like to comment on that?
Yes, I believe that to be the case. Now, I need to go back into literature, and I'm not sure any comprehensive study has been done at this point in time, and it's complicated to assess. But my feeling is, and I believe the feeling of most people looking at microplastics research believe that, yes, inhalation is probably a more significant vector for exposure than either ingestion in food or certainly drinking in water supplies. And down the road, when it's California or New Jersey or any other jurisdiction trying to evaluate whether or not microplastics need to be regulated, that point is not an unimportant question, because you need to have a meaningful opportunity to reduce risk by virtue of regulation. And if drinking water is not a very significant vector for exposure, then perhaps microplastics shouldn't be regulated. But all that remains to be seen.
Thanks, Brent. The next question I have here is, what is the relative source contribution for drinking water versus other ingestion sources?
Yeah, so kind of related to the previous question too. I don't have details about that, but I'll offer one more anecdote. I believe it's widely known that one of the most significant vectors for microplastics inhalation is from airborne particulates from either tire wear particles, especially if you live close to a major road, or the erosion of brake pads, again, from roads. So, and of course, there's plastics everywhere. They're on our clothes, they're on my computer, they're in the plastic cup on my desk, all these things, and they can get airborne just by friction alone. And so certainly it stands to reason that we have much more exposure from that vector than from drinking water.
Makes sense. The next question I have here is, has there been any investigation of private drinking water wells where a lot of folks get drinking water that is not treated by utility? Kind of might be a tricky question to answer, but
yeah, it is. And unfortunately, I don't know that much about private well occurrence. Now, that some of that is out there in the literature, but I'm not that familiar with that at this point.
Thanks, Brent. What is the regulatory outlook for microplastics in general? Could you comment on that?
Yeah, we addressed that just a little bit in the previous question. I think that it's very unlikely microplastics will be regulated in the near future, particularly within the next 5 to 10 years. Now, it's not impossible, but there are so many questions about microplastics, not only as we talked about the relative contribution of drinking water versus air versus food, but also you have to understand, are they toxic? What's toxic? Is it polystyrene or polypropylene? We have to get better about looking for those smaller plastic particulates. And there's just so many questions to answer and those unknowns. It seems very unlikely for the foreseeable future microplastics will be regulated. Now, that doesn't mean your regulator isn't interested in this subject, and it certainly doesn't mean your consumers aren't interested in this subject. So it's one that we certainly need to be aware of as a community going forward, probably on indefinitely. However, in terms of specific requirements, either from the US EPA or individual states, even from California or New Jersey, where the monitoring is moving along, it's probably a very long window before there's any concrete regulatory action about microplastics reduction.
Makes sense. Well, the last question I have here is, what is the most significant innovations need that will help answer some of the critical questions that we have on microplastics in drinking water?
Yeah, I really feel like getting our methods better and being able to peer down, if you use the expression, to that nanometer scale particulate is important, because I didn't show the plot here, but in some of the presentations I gave, we'll show typical particle size distributions for microplastics. And consistently, the smaller you look, the more numerous the particles become. And there was one notable study published in January of this year that looked at bottled water, and they found hundreds of thousands of nanoscale particulates in those water supplies. Now, you don't get down to the very smallest particulates, but even within just below 1 micron, the hundreds of nanometers, they found so many particulates. Will that be true for drinking water? We don't know. But I think until we do have better methods that can detect those particulates, we really can't understand the toxicology better. We can't understand treatment efficacy. So it's almost like we need to roll back the veil with methods before we answer the other meaningful questions that still are on the table.
Thanks, Brent. It sounds like there's a lot of work to be done, but I'm glad we're on the right track, and it's better to get started somewhere. So, well, I think that's a good time to call it. I would like to take a quick minute to thank Brent for taking the time to walk us through your work, and I'd also like to thank you all for tuning in. If you have any questions, feel free to reach out to me directly. I would like to remind you that the slides and recording will be available for download on our website shortly. Also, take a moment to answer the survey questions in the end to help improve our future webcasts. And have a wonderful rest of your day, and we'll see you all very soon on the next one. Thank you.